On this 2019 to 2024 Ram 1500 Classic with the 3.6 Pentastar, P0174 means the PCM is seeing fuel system 2/1 lean. In plain terms, the computer may be adding fuel to correct a mixture that is coming up too lean. The driver may see the MIL, and if the truck has stop/start, that system can be disabled while this code is active. A lean code like this can come from possible air leaks, fuel delivery issues, purge flow concerns, exhaust leaks, MAP or oxygen sensor signal problems, wiring issues, or less commonly, a PCM fault. Start with the basic system checks, then follow a structured diagnostic approach instead of jumping straight to a sensor. This system is trying to maintain a stoichiometric air/fuel mixture of 14.7. 1. Treat the running requirements as monitor gates. Engine running in closed-loop fuel control, battery voltage above 11.0 volts, barometric pressure greater than 75 kPa, ambient temperature above -7 degrees C, 20 degrees F, fuel level greater than 12%, and the altitude condition met. The code sets when short-term and long-term fuel correction added together go greater than a calibrated threshold, generally 133%, where 100% is nominal. After approximately 30 seconds of fail time, the diagnostic fails. Use those conditions to reproduce the problem instead of testing it in the wrong operating range. First, use the scan tool to read and record the DTCs and record the captured operating data. Start the engine and verify the fuel system is in closed-loop fuel control. Then operate the vehicle under the same kind of conditions that set the code, using the recorded data and the monitor conditions. Read DTCs again. If P0174 is active or pending, continue. If it is not active or pending, handle it as an intermittent condition, and do not force a hard fault diagnosis that is not there. Next, look at the recorded DTCs. If other active or pending faults are present in the fuel or air handling side, diagnose those first. They can change the way this lean code is interpreted. If there are no other fuel or air handling codes active or pending, move on to the MAP sensor operation check. Run the MAP sensor operation test. If that test finds a MAP-related problem, correct that problem and then verify the repair. If the MAP check passes, shut the ignition off and inspect the mechanical and air side areas that can create a lean condition. Check the air induction system for leaks. Check the engine and all vacuum lines or hoses for vacuum leaks. Check the brake booster for an internal vacuum leak by watching engine speed and vacuum while pinching the vacuum hose going to the booster. If a restricted injector is suspected, remove the fuel rail with the injectors intact. Keep fuel pressure in the rail by energizing the fuel pump. Actuate the suspect injector or injectors with the scan tool and compare the spray pattern to the others. Also check the purge flow system for free flow, leaks, restrictions, and the hose and connections between the purge solenoid and intake manifold. Engine compression must be within specifications. If a mechanical problem is found, correct it and verify the repair. If not, continue to fuel delivery. Now check the fuel delivery system. If a fuel delivery problem is found, correct it and verify the repair. If fuel delivery checks out, check the ethanol content in the fuel. If the gasoline has an ethanol content issue, correct that condition and verify the repair. If the fuel content is okay, check the exhaust system for leaks. An exhaust leak can mislead the upstream oxygen sensor and drive the fuel trims lean. If an exhaust leak is found, repair it and verify the repair. If no problem is found there, move into the upstream oxygen sensor wiring checks. For the upstream oxygen sensor wiring check, disconnect the upstream O2 sensor harness connector and disconnect the PCM-C2 harness connector. Connect the adapter, GPEC Diagnostic 10436, to the engine harness side of the PCM-C2 connector. Do not connect the GPEC Diagnostic adapter to the PCM. Also, Do not probe the PCM harness connectors. Probing those terminals can damage them and create a poor terminal-to-pin connection. With the adapter in place, check the upstream O2 sensor circuits between the O2 sensor connector and the adapter for a short to ground, and for an open or high resistance. If a wiring problem is found, repair the open or short circuit and verify the repair. If the wiring checks good, continue to oxygen sensor operation. Run the oxygen sensor operation test. If that test finds an O2 sensor operation problem, correct the O2 sensor operation concern and verify the repair. If the O2 sensor operation test does not find a problem, go to the related harness connection checks before condemning anything else. Disconnect all PCM harness connectors, any related inline connectors if equipped, and the related component connectors. Inspect the harness connectors, component connectors, and male and female terminals for proper installation, damaged locks, corrosion, water intrusion, seal damage where used, bent terminals, overheated or discolored terminals from poor connection, and terminals pushed back into the connector cavity. Check for spread terminals and verify proper terminal tension. Repair any conditions found. Then reconnect the PCM connectors, inline connectors if equipped, and component connectors, making sure everything is fully seated and all connector locks are engaged. Erase the DTCs, operate or test drive the vehicle under the monitor and set conditions, and read DTCs again. If P0174 returns after that, this diagnostic path supports replacing and programming the PCM, then verifying the repair. If it does not return, the wiring or poor connection issue has been corrected, and the repair still needs to be verified. Keep the verification step separate from the testing. Anytime you repair a found problem on this path, clear the code, reproduce the operating conditions, and confirm the code stays gone. The takeaway is simple. P0174 is a lean correction code, and on this truck the diagnostic path works from active code confirmation, to air and mechanical causes, to fuel and exhaust checks, then oxygen sensor wiring and operation, and only then connector integrity and the final PCM decision. For more diagnostic training, visit stepdiagnostics.com.